Welcome to my knowledge. In today's video we will discuss 3D modeling in detail. So let's start AutoCAD. Today I will be using Zoom It software for zooming the cursor. Let me know if it's okay to use it or is it disturbing you. Kindly let me know in the comment section. I'm using it to show you the icons clearly, but if you can see it without Zoom It software, then I will not use it in the upcoming videos. So please let me know. So the first thing I'll be doing is go to the Workspace Switching icon. By clicking on it, I can select 3D modeling. Currently it is in 2D modeling drafting mode. So after changing it to 3D modeling, we will observe that the icons on the ribbon have changed. We still have the draw commands from 2D modeling, but box, extrude, poly solid, press pull, mesh, etc. have been introduced in 3D modeling window. We will be discussing each and every icon in this tab. To begin with 3D modeling, the first thing I'll be doing is to set units. To set units, I've just typed UN and in command line. After that, this drop down menu will show up. From here you can change the precision, change decimal, degree, grades. You can also switch it to radians. Precision can also be changed clockwise or anti-clockwise. Units, I'll keep it in millimeters. We'll press OK. It's good. After that, I will try to set limits of my page that I'll be using or the workspace. It's the same as we discussed in 2D drafting. I'll type limits, then just like drawing a rectangle, I will give it first point and second corner. So the first the coordinates of the first corner are 0, 0, while the coordinates of the second corner is 500. Now let's discuss some toggle keys. The first is grid mode. You can turn it off or on. When you turn it on, it will show you grid on the workspace. If you turn it off, the grid will disappear. So it's up to you. If you want to use it, you can keep it. After that, ortho mode is when you want to draw perpendicular or horizontal lines. Suppose I want to draw perpendicular and horizontal lines, I will turn on ortho. Just like this, it will only draw perpendicular and vertical and horizontal lines. To change angle, I can use polar. So that's the difference between ortho and polar. In polar you can give any increment of angle. Currently it is on 45, 90, 135. You can change it to 30, 60, 90, just like this. So at every 30 degree increment it will indicate me the angle. After that, we can turn on and off the OSnap. In OSnap settings, we have endpoint, midpoint, center point, nodes, intersections. So what does this mean? Let's demonstrate it. If I draw certain lines and I want the cursor to show me the endpoints of this line, the midpoint of this line, the intersections, I have to turn that option on. See, it is showing me the intersections, it is showing me the midpoint. It is showing me intersection and midpoint as well. It will also show me center point of a circle or arc if I draw one. Now let's draw some 3D models. We have built-in box, cylinder, cone, sphere, pyramid, wedge and torus shapes. We can use these built-in 3D shapes, or we can draw our own. We'll do both of them. I'll just click on the box, click anywhere, then give the horizontal dimension. Suppose I want to draw a box of 15, then I'll press comma or tab and enter the other dimension, 15 as well. So if you can see, there is a tiny square in the workspace. We have to zoom it. The third dimension that I entered was the height of the box. It was also 15, so it will be kind of a cube. Currently we are seeing its top view. To see the object in 3D, you have to change it into isometric view. This is the isometric view. If you see the box is in 3D, but from top it looked like a square. To see it as a solid, I'll go to view. From view, I'll click on conceptual, and now the box is like a solid cube. I can choose any view out of these. I will be using shades of gray. Again, let's move to top view. Then to see another isometric view, you just have to click on the corner of that box. It is west north isometric. To rotate it, just click on that small box and move the mouse around. You can see the box from any direction. Another option, this little hand, it is for panning. You can pan it by clicking on the object and move around the mouse. To exit from any command, you have to press escape. To zoom in, zoom out, just scroll your mouse wheel to orbit. Click near the 3D model. Click and hold it near the 3D model. Then by rotating the mouse or moving the mouse, you can rotate the object. Another easy way is by holding shift key and clicking on the wheel. You can spin the object as well, or orbit it as well. Now let's move to another solid object, that is cylinder. For cylinder, it is asking me the center point of the base of the cylinder. So I'll just click randomly. Then I will put the radius as 15 and the height of my own required height, that is 25. So this is how you draw a cylinder. If you want to draw a cylinder, this is the easy way. Then cone. If you want to draw a cone, again it is asking for its center. I'll just pick it randomly, then radius and height. So the height is 30. After that, we have sphere. In sphere, it will only ask me the center point and radius of the sphere. So I'll just draw a sphere of 15 radius. Then a pyramid. To draw a pyramid, you need to specify the center of the base rectangle or square, and then the radius that inscribes the square. So the radius of a circle that inscribes the square is let's suppose 15. Then I can extrude it in negative and positive height direction. Let me just extrude it up to 30. So this is a pyramid. After that, these are the built-in solid objects that you can draw. If you want to draw a wedge, it's the same as we did in rectangle. You have to specify two corners of the base of the wedge. Suppose the sides are 15 and 15. After that, we'll just assign the height of the wedge, and let me enter 30 as a height. After that, a torus that's like a donut shape. So you have to specify the center, then you have to enter the radius of the bigger circle. Now you have to specify the radius of the rounded area, that is 3. So the radius of the cross-sectional area was 3, and that's how you draw the built-in features in AutoCAD. Now we'll move to Extrude command. For Extrude, I will use a rectangle. Suppose I want to extrude a rectangle like this. I'll just place a rectangle, then click on Extrude, select the rectangle, press enter. Then it will ask me to specify the height, and let's suppose the height is 45. So this is how you can draw by using Extrude command. Now let us use lines. When I draw something using lines, the lines should intersect each other. So when I draw something from lines, it doesn't extrude like it was like it happened for a rectangle. So when I draw something from lines, it doesn't extrude like it happened for the rectangle. It is because all the lines are not joined with each other. They are in contact, but they are not representing a single polyline. So to convert it to a polyline, select all the lines, enter J and press enter. Now when I move cursor on it, it shows a single polyline. It's like that. Now to extrude it, just use the same command, extrude, select the line, press enter and enter the height. If you use polyline instead of line command, you don't have to join the end feature, the end product. Suppose I want to extrude this, I can extrude it directly without joining it because I used polyline. So for line, you must have to join the lines first before extruding them. Another thing is, all the joining lines must create an enclosed area. This is enclosed area. Now when I extrude this, Although it is enclosed, but they are not joined, it will still not extrude as a solid but a sheet or a surface. So if you want to draw a surface, you can use line. If you want to extrude any area, you have to create area first. That's the point. Now let's move to Loft. Loft is used to extrude something with different cross sections at varying height. Suppose a bottle or a bowl which has different cross sections at different heights. So I will just draw 3 cross sections. Three different cross sections. The first one was 20, then 40, and the last was 30. After that, I will use Move Gizmo. Just click on Move Gizmo, then select a circle, then select a circle that you want to move. The gizmo will appear. Now by dragging it in Z direction, I can move it up to the required height. Suppose I want to move it up to 80 millimeters. After that, I will select the second circle and move it upwards up to 60, or let us move it another 10 millimeters. So now using Loft command, I can make a bowl shape. Now using Loft command, I will select base circle, then midway circle and the top cross section to make a bowl shape or a solid with different cross sections. You have to press enter at the end, and that's how you make a lofted shape. Let's make another example. I'll just draw a rectangle and place a circle inside it. I'm just trying to show you that you can join different cross sections using Loft command as well. I'll just move this rectangle up to certain distance or certain height, suppose 100. Now using Loft command, I'll select the base circle and click on this rectangle, then press enter, and this is how you can make varied variable cross section solid parts. Revolve command is used for things that are symmetric around or about an axis. I will turn on the Ortho Mode and draw half cross section of something that I want to revolve. I'll just move 10 downwards and join these 2 points. Press escape. To revolve it, I must join these lines. Select these two. J, enter. So I've joined these, made it a single polyline. Now I'll select the axis about which I want to rotate it. Then after pressing enter, I will select the points of the axis. When I click on it, it will automatically show me the revolution of the cross section. You can see it. It's just like a dumbbell. You can rotate it up to 90 degrees. You can rotate it up to like this. It will look like this. If I rotate it up to 90 degree, I can rotate it up to 180 degree. I can rotate it up to any degrees between 0 to 360. Now I'll just rotate it 360 and press enter. So this is how you can build a dumbbell very easily. So another command that is sweep, which is very useful. We have to, in sweep command, first we have to draw a path. I'll turn off ortho. You just have to draw a path on which you want to sweep something. Suppose I draw a path like this. I'll draw an arc as well. No matter how twisted and turned the path is, you can sweep any cross section on it. So now I want to sweep a circular cross section on this path. I will draw a circle at this point, as this is the starting point. The radius of the circle will be 4. Now go to sweep command, click on sweep, select the cross section first, click on it, press enter, then the path. When I click on it, it will create a 3D object with a cross section of that circle and the path of that line. I'll do the same for the arc as well. I will draw another circle on this end of the I will draw another circle. I will draw another circle on this end of the path. The radius of the circle will be 4. Then using sweep command again, I will select the circle, press enter, then the path, and it will get swept over this path. And this is how you can create any cross section and sweep it along the path that you want to draw. So this is how you can do 3D modeling of pipe, or fencing can be done using this. You can also create railings. You can also create stair railings, anything that you want to sweep. Now another command, that is press pull. It is very useful. Suppose I have this cross section. I'll just move my cursor inside this cross section, click on it and drag to the height that I want to, and then press enter. It is very easy. So press pull can be used for extrusion as well, but the condition is that the cursor must fit inside the area that you want to press pull. One thing that I forgot in sweep command, that you can also create cross section with a hole. Like I want to create pipe. I will give the external dia of the pipe, that is 4. Then internal diameter, suppose the internal diameter is 3. Now I'll go to sweep command, select both of the circles, press enter. Now select the path, and this is how you can create a pipe. So now you can use sweep command for creating a pipe model or a solid rod or anything else that you want to. You can also sweep a rectangular, pyramidal, a square, or any polygon. You can also sweep these kind of cross sections. Now using press pull, I want to demonstrate how you can create a hollow cylinder. Draw 2 circles using press pull. Click between these 2 circles, and then you can drag a hollow circle just like that. Now I will just rotate it a little, take my press pull cursor there, and this is how you can make a solid as well. When I press space, the press pull height will automatically be equal to the previous press pull command. I can also use press pull command for subtracting, like I'll select this circle. If I drag it up, it will create a cylinder on top of it. But if I select it again using press pull and drag it down and click it, it will subtract the same cylinder from that rectangular block. I can regenerate it again using press pull. So press pull is like an easy version of extrude. Suppose I draw a rectangle. And press pull it, it will work. But if I move this rectangle above my workspace using move Gizmo, if I drag this rectangle above this workspace surface, above XY, if I move it above XY, and then as it's above XY now, and now try to press pull it, it won't work, because for press pull it is must that the surface should lie on XY plane. So if it is not on XY plane, extrude will work. If I click on it, press enter, extrude will work, but press pull won't. So to make it work, I have to go to UCS, type UCS, and place the coordinate system here. The first point is the origin. The next point will show x-axis direction and the second will show y-axis direction. So now the x, y are on the rectangle. If I go to press pull, it will start working. So this is how you can change the coordinate system using UCS and to enable the press pull command. For extrude, you do not need to change the UCS, but for press pull you must be in the XY plane. To move something, it's very simple. Type move command, click on the object and select the corner that you want to move. I'll just place it randomly. Right here, just to show you how union and subtraction works. Now if I move the cursor on it, you can see all these three objects are separate, not a solid union. To make it a solid union, select both of the objects, press enter. Now when I move a cursor on it, it will show me union of these two. For subtraction, I will move this block from here and place it on this edge. Now I want to subtract the smaller block from the bigger block. I will go to subtract command, select the bigger rectangle from which I want to subtract the smaller one, and after that I will select the smaller one and press enter, and that's how subtract works. So select this first, the bigger rectangle, then the upper feature, and that's how subtract works. I'll go to UCS once again to show you how to place coordinates. At first you will place the origin, then the x-axis direction and the y-axis direction. The z is in upward direction. So if you want to see where your z will be, curl your fingers from x-axis to y-axis. The thumb will show you direction of z-axis. Now to fillet something or fillet something, or give or to give radius to an edge, just click on fillet. Select first object, which is this edge. Now enter the radius. I'll put 4 radius, press enter, and that's how you can fillet something. Now I will show you how to move a 3D object. Just click on the 3D move command. Now I will show you how to rotate an object. Just click on the rotate command, then click on the object, press enter. You can rotate it in every about every axis and move it in every direction. Now to scale up and scale down an object, click on 3D scale, and when you can scale it up and scale it down. So that's it for today's video. Kindly subscribe if you liked the video. Thank you.